Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we're going to go over some work rate problems. These are applications of rational equations. In this problem, the idea, let me write it up here, is if you take the rate that a person or a machine works at, multiplied by the time that they work, you will get the part of the job completed. Now these typically will have two or more people or machines doing a certain task, and at the end the task will be completed, so the portion of the job completed will add up to equal 1 for the different individuals, and that's where our equation will be. In this problem it says Rob takes 5 hours longer than Genevieve to paint a room. If they work together, they can paint a room in 6 hours. How long does it take Rob to paint a room by himself? So we've got rate, time, and the part completed. And we have Rob, Genevieve, I'll just abbreviate that, and so the first thing that I know is that Rob takes 5 hours longer than Genevieve. So Genevieve's rate can be expressed as 1 over x. If she can do it in, let's say, 10 hours, in 1 hour she can do 1/10, 1 over 10. So the rate is always 1 over the time it takes that individual working alone. Rob takes 5 hours longer than her, so his rate is going to be 1 over x plus 5. The time comes from the fact that they can complete the room together in 6 hours. So if they work together in 6 hours, the job will be complete. The part of the job done by Rob is 6 over x plus 5. The part done by Genevieve is 6 over x, and that is going to add up to equal 1. So this is where my equation is going to come from for this problem. All right, let me change the orientation on this so we can see more of the solution at once. So we've got 6 over x plus 5 plus 6 over x equals 1. The LCM is going to be x times x plus 5. Just listing the two denominators. Here, x cannot be 0 or negative 5. It couldn't be 0 or negative 5 anyway. It can't take Genevieve 0 hours to paint the room, and it definitely can't take her negative 5 hours to paint it. So those two solutions we really don't have to worry about anyway. I'm going to multiply through by the LCM. X times x plus 5, x times x plus 5, x times x plus 5. On the left side, divide out the x plus 5s, I'm left with 6x, plus. In the second fraction, divide out the common factor of x, I'm left with 6 times the quantity x plus 5. Distributing that through, I get 6x plus 30. On the right-hand side, multiplying by 1 doesn't change anything, so I just have x times x plus 5, which is x squared plus 5x. 6x plus 6x is 12x, so I'm going to subtract 12x from both sides to move that x term over to join x squared. I'm also going to subtract 30 from both sides, and my new equation will be 0 equals x squared. 5x minus 12x is minus 7x minus 30. Now I'm going to try to solve this by factoring. Here, if it does factor, because it's x squared, it will start with x and the two factors. I need two numbers that multiply to 30 but subtract to be 7. Those are 10 and 3. And it's going to be x minus 10 and x plus 3. The two solutions I get are x equals 10 or x equals negative 3, which we know is impossible in terms of this problem. It can't take negative time to do that. So 10 hours is my solution for x. Let's go back and figure out what we're asked for. It says, how long would it take Rob working alone. So that 10 is going to go in for Rob's time. Again, Rob's time is x plus 5. Genevieve's is x. So Rob's time is going to be 10 plus 5, or 15 hours. If you were asked for Genevieve's time, it would be 10 hours. Okay. Let's try one more. One small pipe takes 20 minutes to fill a tank. That should say takes 20 minutes more. Bad copying by myself. Takes 20 minutes more to fill a tank than a larger pipe. If the two pipes take 30 minutes to fill the tank when working together, how long will it take each pipe individually to fill the tank? So I'm going to do just a slight change on the table here. So we've got pipe number 1 and pipe number 2. And in addition to the rate, the time, and the part of the job completed, I'm going to add in the time individually. So pipe 1, I'm going to let that be the smaller pipe. It takes 20 minutes more than the larger pipe. So x plus 20 and x are the two times. The rates are the reciprocals of those, 1 over x plus 20 and 1 over x. The time, we're told that they could do it in 30 minutes. So I'll put 30 there. And then I multiply rate times time to get the part of the job completed. That's going to be 30 over x plus 20 and 30 over x. And those have to add up to equal 1. The only reason I added the individual time column is that when I go to look for presenting my solution, it's going to be easier to go directly back to that column instead of looking at the denominator of the rate. Right. Let's try to set up and solve this equation. I've got 30 over x plus 20 plus 30 over x equals 1. The LCM is x times x plus 20. The two solutions we would have to omit would be 0 and negative 20. So again, those aren't really concerns here. Let's multiply through by the LCM. X plus 20, x plus 20, x times x plus 20. On the left side, the x plus 20s cancel in that first fraction, leaving 30x plus. Divide out the common factors of x in the second fraction. I've got 30 times the quantity x plus 20. That's 30x plus 600. Distributing that 30 through. Finally, on the right-hand side, 1 times x plus 20. I just need to distribute x. I get x squared plus 20x. Just like the last one, 30x plus 30x, that's 60x. So I can subtract that from both sides. Also subtract 600. And I end up with the equation, well, let me move this over a little bit, I'm going to need the room. 0 equals x squared minus 40x minus 600. Now again, I would try to factor this if I could, but I don't know two numbers that multiply to 600 and subtract to 40. Also, where it says round to the nearest tenth of a minute, that has me a little concerned that I need to use the quadratic formula anyway. So I'm going to jump right to that. X equals the opposite of b, that's the opposite of negative 40, or 40, plus or minus square root of b squared, so negative 40 to the second power, minus 4ac is minus 4 times 1 times negative 600. And that's all going to go over 2 times 1. Let's simplify within the radical first. X equals 40 plus or minus square root. Negative 40 to the second power is positive 1,600. And negative 4 times 1 times negative 600 is plus 2,400. And that's all going to go over 2. Finally, we get x equals 40 plus or minus the square root of 4,000 over 2. And here, I would try my calculator, see if I can do the square root of 4,000. Let me show you what I mean. I'm going to open up the Desmos scientific calculator. And I'm just going to type square root 4,000. And notice I get a decimal. So I don't know what that is. So the next thing I'm going to do is I'm going to go right to the quadratic formula results and try to simplify those. 40 plus square root 4,000 over 2. And by the way, we can pull some factors out of the 4,000, but since we need a decimal answer, we might as well just go right for that. Fraction 40 plus square root 4,000 all over 2 in the denominator. I can see that's 51.6, and I did need to the nearest tenth of a minute. So let me write that one down, 51.6. Maybe the other will work too. 40 minus square root of 4,000 over 51.6. Now we already saw that the square root of 4,000 is over 60, so that numerator, oops, it's supposed to go over 2, not 51.6. So that numerator is going to be negative. You can't have negative time. So I know this one's not going to work, but I'm going to go through the motions anyway. All I have to do in Desmos is tap in the numerator, and where the plus sign was, I'm going to backspace and replace it with a minus sign. And notice there, I've got negative 11.6. Approximately negative 11.6. That's impossible. So x is 51.6. Now I can come back to the times. Let's try it like this. To those times. I want to put in 51.6 for x. The smaller pipe is x plus 20. 51.6 plus 20, that is 71.6 minutes. The larger pipe was just x, that's 51.6 minutes. All right. So those are our work rate problems. You want to try to set them up the same way that I did, and a lot of them get solved in the way that I solved them. Once you get down to your quadratic equation, then you've got some choices to make. I really recommend trying to spend, your 5 or 10 seconds on trying to solve by factoring. If the factoring doesn't jump out at you though, don't waste too much time. You can always switch over to quadratic formula. All right, in the next video, we'll move on to a different type of equation to solve.